Jai Hind everyone, my name is Ankita Rani. I am working as an assistant professor in the Department of Computer Science and Engineering. Today I am going to discuss the topic association rule mining in the data analytics, and the subject code of data analytics is BCS 052. So what is association rule mining? A key technique in data analytics to discover the relationship between the variables in large data set is called the association rule mining. Basically, in association rule mining, we create the relationship between the different variable in large data set. For example, we have many transactions, we have many variables in the data set. So we can check that relationship in the association rule mining. We can create the association between the data sets. So association rule mining identifies interesting relationship or the rules among variables in large data set, and the most widely used example of association rule mining is market basket analysis. In market basket analysis, we use the concept of association rule mining. For example, in market basket analysis, when you go for the shopping in the market, so the system know that your pattern of marketing. For example, you buy the same product every time you go to the market. So the product is noted down through the machine, and the next time you will go to the market, they suggest that product. So this is the concept of the market basket analysis, and this comes under the association rule mining. So the concept behind the association rule mining is is divided into three parts. There are three concepts in the association rule mining. First is the support. In support, we calculate the frequency of item set, the occurrence of the item set, how many times this item occur in the, and the next is confidence. Confidence is the likelihood of rule. Means how the possibility of the event of to occur, and what are the rules in the between the different variable in the data set. Third is the lift. So in lift is the strength of rule compared to random chance. So these are the three key concepts which we used in the association rule mining or the, market basket analysis concept. So there are the different formulas. So this is the formula of support. In support, we can calculate, for example, A and B is two variables, two item sets. So the probability of occurrence of A tends to B. So measures how frequency item appear together in data set. So through support, we calculate the frequency of any item set. Frequency of item set. For example, we have an item milk, bread, butter. For example, the occurrence of a milk is 3. This means that frequency of the item milk is 3, bread is 2, and butter is 4. So this shows the frequency of item set. We can calculate that frequency through the formula of the support. So support is used to calculate the frequency of the item set. Next is confidence. The formula of confidence is A tends to B is equal to probability of B such that belongs to A. So measure reliability of inference. It measures the reliability, means it calculates the likelihood of rule. So in that case, we check the probability, we check the reliability of inference, we check the probability of rule. Next is the lift. In lift, the formula of lift is this: confidence divided by the support. The value we calculate from the from two variables to data set is that confidence is divided by support. So this is the formula of lift, and if lift is greater than 1, then they indicate strong association between the two variables, between the two data sets. So these are the three concepts of the a priori of the association rule mining. So the next concept comes under the association rule mining is a priori algorithm. This is the example for calculating the frequency of item set. So a priori algorithm, what is a priori algorithm? A priori algorithm is a basic method used in data analysis to find group of items that often appear together in large set of data. So in this we find the group of items. Group of items. So in that case, it helps to discover useful pattern or rule about So a priori algorithm is a basic method used in data analysis to find group of items that often appear together in large data sets of and also it helps to discover useful pattern or rule about how items are related, which is particularly valuable in the market basket analysis. So with the help of the concept of market basket analysis, we use the concept of a priori algorithm, and also in this we generate the frequent item set, we calculate the frequency of item set, and we uses the support threshold, and we prune the infrequent data item set. If the probability of item set is 1, which is less than the confidence, then we prune that item set. So prune infrequent item set. Next is the steps of a priori algorithm. First step is the generate candidate item set. First step is generate candidate item set. After generating the candidate item set, we calculate the support. After calculating the support, if the item set value is less than support and less than, then we prune that item set. After that, we repeat until no new item set are found. So these are the steps, and now we discuss these steps in detail with some example of the a priori algorithm. So this is the example of a priori algorithm. In this example, let's understand the concept of a priori algorithm with the help of an example. Consider the following data set. This is the data set is given, and we will find frequent item set and generate association rule for them. So in this we have 5 transaction ID, T1, T2, T3, T4 and T5. These are the 5 transactions. In first transaction, the items bought are bread, butter, milk. In second transaction, we purchase only bread, butter. In transaction 3, we purchase bread, milk. In transaction 4, we purchase buttermilk. In transaction 5, we purchase bread, milk. So this is the item set, and now in this item set, we can apply the a priori algorithm. We can apply the steps of the a priori algorithm. First one is the setting the parameter. So there are the 2 parameters, support and confidence. First parameter is support and second parameter is confidence. So minimum support threshold is 50% and confidence threshold is 70%. How this is calculated? Because item must appear in at least 3 to 3 by 5 transactions, this threshold is formulated from this formula. This is the formula for calculating the threshold. So in this you can see that how many times the bread will come. 1, 2, 3, 4. 4 times the bread will come, and 1, 2, 3, 4. 4 times milk is come, and 4 times butter is come. So after that we can calculate the minimum confidence. Minimum confidence threshold is 70%. You can change the value of parameter as per the use case and problem statement. This threshold is formulated by using this formula. This is the formula of the threshold. So step 2 is find the frequent item set. Find one frequent item set. So let's count how many transactions include each item in the data set. It means we calculate the frequency of each item. After calculating the threshold and support value, we calculate the frequency of each item. After this, all items have support if is greater than or equal to 50%, so they qualify as frequent one item set. If any item has support less than 50%, it will omitted out, it will pruned from the frequent one item set. So in this table we can calculate that the possibility of bread is 4, support count is 4, and the support count of butter is 3, and milk is 4. Because in that you can see that bread is 4, 1, 2, 3, 4, butter is 1, 2, 3, and milk is 1, 2, 3, 4. So this is the count of item set. So after this, support count is 4, then support percentage is 80%. If support count is 3, then percentage is 60%. If 4, then 80%. This is the support count, and this is the frequency of occurring these items. After that, in third step, we generate the candidate 2 item set. Candidate 2 item set means C2. So combine the frequent one item set into pair, and in this step we can now pair the data item like this. For example, bread, milk, butter, milk. So in that step we calculate these. So combine the frequent one item set into pair and calculate their support. For this use case we will get 3 item pair. So from that table we can generate 3 item pair. First is bread butter. This is the one set. Second is bread milk. And third one is buttermilk. So these are the 3 pair in this we generate. So combine the frequent one item set into pair and calculate their support. So for this use case we will get 3 item pair, bread butter, bread milk and buttermilk, and we'll calculate the support similar to the step 2. So frequent 2 item set, bread, milk meet the 50% threshold, but butter, milk and bread, butter does not meet the threshold. So will be committed out because the value of this threshold is less than 50%. So after that we generate item pair bread, butter. The possibility of bread, butter is occurrence frequency is 4, percentage is 80%. Bread, milk is 3, so it's 60%, and butter, milk is frequency is 4, so 80%. So this table is generated in this step in candidate set 2. After that we generate the candidate set 3, candidate 3 item set. In this we combine the frequent item set, we combine the frequent 2 item set into group of 3 and calculate their support. For the triplet, we have got only one pair and we will calculate the support. We will calculate the support. This is the pair we can got because in this the pair is bread, butter, comma milk. So the only pair we can get from this table is bread, comma butter, comma milk. The only pair we can get from this data set, from this table. So the support count of bread, butter, milk is 1. So the support count is 20%. So since they does not meet the 50% threshold, so there are no frequent 3 item set. So in this step, we don't have any item set because it does not meet the criteria of the threshold. This is the table. After that, we generate the association rule. Now we generate association rule from the frequent item set and calculate the confidence. So rule 1 is if bread, butter, if customer buy bread, the customer will buy butter also. If the customer buy bread, then the customer will buy the butter also. So the support is 2 and the support of bread is 4. We divided by 2 by 4. The confidence value is 50%, which is failed threshold. Rule 2 is if the customer buy the butter, then they can also buy the bread. So the support of bread, comma butter is 2 and support of butter is 3. 2 by 3 is 66.67%. So this threshold is also fail. After that, rule 3 is if customer buy the bread, then they also buy the milk. So the support of bread, comma milk is 3 and the support of bread is 4. The confidence is 3 by 4, the 75%, they passes the threshold. So the a priori algorithm as demonstrated in the bread butter example is widely used in modern startup like the Zomato, Swiggy and other food delivery platform. These companies use it to perform the market basket analysis, which helps them identify customer behavior pattern and optimize recommendations. So these are the some applications of the a priori algorithm. First is the e-commerce. We use the a priori algorithm in e-commerce used to recommend products that are often bought together like laptop plus laptop bag, which increase the sales. Second is food delivery services like in Zomato, Swiggy, for example, identify popular combos such as burger plus fries to offer combo deals to customers. After that, the next application is streaming services. So recommend related movies or shows based on what user often watch together, like action plus superhero movies. Next application is the financial services. In financial services, analyzes the spending habit to suggest personalized offers such as credit card deal based on the frequent purchases. Next application is travel and hospitality. So they create travel packages like flight plus hotel by finding commonly purchased services together. Next application is health and fitness. They suggest workout plan or supplement based on user past activities like protein shake plus workout. So they suggest the combos, they suggest the frequently bought items with the help of the a priori algorithm. So in this field, we use the concept of the a priori algorithm. So these are the some advantages of a priori algorithm of or association rule mining. First is easy to understand. Next is useful for large data set and it also helps in the decision making. There are some limitations also. First is computationally expensive, or next is they produce many rules because the frequent item set is many, and if they are the large data set, and they need the threshold tuning also. So these are the limitations. At last, we conclude that association rule mining is powerful for discovering the hidden pattern and is powerful for the large data set, and it also useful in multiple domain on the of the data analytics, and in the real time we also use the concept of the a priori algorithm.